Hey everyone, Spetcher, congrats on the first. Cytos, your squad and math club meeting today and was themed around Pie Day. They brought some pie that can eat because it contained milk and I'm vegan. No, wait, pie that contains milk. It's an interesting ingredient. I guess unless you, if you, I only know using milk and pie to brush it on the crust, but it could be that, I guess. Um, Give the kids a problem, or it could be like cream pie too. It doesn't matter. I gave the kids the problem with the square and four inscribed quarter circles. Oh yeah, where the goals find the area of the middle section. They enjoy that. Nice. Um, So we're gonna start stream off. The Viking posted a question in Discord yesterday, so we're gonna work through this one. They posted what they got, and let's see if we can get instant matches or not. Do we not do this exact one? This looks really familiar. Wait, I didn't actually read it until now. Um, I need to. I did do this exact one. I didn't realize that. Though I can double posted this. I wonder if that was just the wrong screenshot or what. All right, back to them. Okay, well, never mind. I'm not gonna do this question twice. Um, Okay, so what I had planned it otherwise for the downtime was linear algebra. So I've been going through the MIT OpenCourseWare YouTube lectures from Strang, and I feel like I understand the concepts he's talking about, but I want some practice with the like doing problems for myself, and I was having trouble finding a good source of problems. And I thought, why not actually check the description of the YouTube video? Hey Jaden, I'm good. How about you? And sure enough, it has it like the Linear Reports its own little like website along with it. Um, Doing well. That's good to hear. And I tracked down the book. Oh wait, the Viking already got back to me. Ugh. Sorry, I'm reading what this person was putting. I don't really want to work through it twice. Here I'll show what I'm looking at. I'm just trying to look. So I think I just checked through the this work. I didn't do all these for myself. Your math class right now? Oh God, Jaden, you should probably pay attention. Yeah, lock in. Okay, I only had an issue. Number 1, 3, and 5. Hmm. Okay. Um, so this is from the fourth edition of the textbook that Strang wrote. I actually managed to find the fifth edition, but I don't care about doing the exact things that are pointed out here. I just want to kind of grab some interesting looking problems. Um, I play chess a little bit. On Lee chess, I'm like uh 1500 ish in 3+2. It's like on chess.com, it's like 1200 or so because Lee chess ratings are kind of inflated. I mean, I know enough chess to beat like the average person who doesn't play chess. Hey, my engineer study blog. But against someone who actually knows how to play chess, I get annihilated. I kind of want to look in, I guess, into orthogonality. In lectures, I've just gotten to eigenvalues. Someone called chess. Yeah. So who knows? Speaks looking from better at chess than the average person. I mean, that's true. If you took the entire population of the Earth, I would say that most people don't know how the pieces move. A little cutoff there is really annoying. Give you a PDF of this book. Um, if you just Google Introduction to Linear Algebra string, like put that exact thing in Google, and you'll find it. That's true. You have never lost to Magnus Carlsen, so you know that's more than like Hikaru can say. Oh, yeah. I'm sorry, Imagineer Study Blog. I don't know anything about it. You're gonna have to. you're gonna have to find a textbook for yourself, but just put the name and author of the textbook into Google with PDF, and you can usually, especially for older editions, you can usually find something. Ooh. Okay, number three looks like it could be cool. You're gonna have to do your own research for that, my engineer study blog. I'm sorry. Well, I don't need to write three again. Just write A. Okay, so to assure ourselves that we have a null space, well, okay, first we can get the column space condition just by putting the given vectors as columns. And then I think like we can add on one or two more vectors here. Um, yeah, that too, that YouTube doesn't like links. Yeah, like you really don't need someone to give you a link. Just use Google. It's really not difficult to find. um, we want the null space to contain 111. So what do we get if we add these two columns? Just so I can see it. 3 minus 1, 2. Can we take some like scalar multiple of this? That would it. Well, the scalar multiple piece shouldn't affect it. Hmm. What does it mean if the null space contains 1, 1, 1? I mean, you could post it to Discord, but I promise you, if you just be brave and take the step to type it into Google, you'll find it. You really don't need other people to like dig it up for you. It's just kind of right there. Dad saving so ass. Eldritch, I completely agree. Okay, so in order for the null space to contain 111, this matrix must be 3 by 3 with the third column dependent. Or potentially, oh, no. Hey, Rex. Okay, so yeah, same, John. it's terrible for everything. Like I think it's the sites that show that there's more car crashes that happen on daylight savings time because people are just so messed up by it. Um, oh, you know what? Maybe we can do this. Maybe we take this and multiply it through by -1. Because now 111 would definitely give us zeros across the top there. And there, and there. Okay, I think we did A. This is our matrix. Now we need, for part B, we need to do the same thing with the row space containing that. So we can have, it's still going to be 3 by 3 for the same reason, I think. It can't be 2 by 3 because we have to contain these two rows. And these two rows are independent, so they can't have a null space besides 0, 0, 0. And we can't go to 4 rows because that would make the null space 4-dimensional. No, it wouldn't here. Wait. Doesn't 111 also work here? But this is a rank 2 matrix. AIM or USAMO? No, I don't really like competition math. You have to do so much studying to learn the tricks that they use, and I find the problems a little pointless. Like I'm an applied math person, so I enjoy math when you see like why it's useful. Technically, this would be happy PDE. Oh, Pi Day Eve. I was like partial differential equation. You too, Jed. I feel like I'm being tricked here. Like, there's no way it's just this matrix. But it just works. Like, 111 does solve this. Hey, Central. I guess this is my answer. I do have the solution manual for part. I feel very weird about part A and B. I feel like there should have been something more that I'm missing. Is it possible to have a matrix A such that AX equals 111 or AX equals 111 has a solution and a transpose times 100? So 100 is a vector in the left null space. Okay. Good luck to you, Lucas. You have a question? Yeah, what's up? In limits, is there a difference when you have 1 over 0? When you use 1 over 0 plus and 1 over 0 minus? There can be. Only 0.3 to go. 1/10, one. Wait, what? Just barely muted in time. Wait, for part B, multiplying the second row by 1 on 1 gives 4. Oh, you're right, Lubert, it does. Okay, I need to raise a part B. Let's talk about Luke's question first, though. Tekken table. It's clearly a place where you play Tekken. So this is where it's important to understand the graph of the thing that you're doing limit of. So like, if we take 1 over x, oh, I see, Jed. Yeah. 1 over x looks like this. Oops. So if we're approaching 0, it definitely matters if we're approaching from the positives, where we get positive infinity up here, or if we're approaching from the negatives, where we get negative infinity down here. So if that is like the Tekken table thing, or I'm sure I'm pronouncing that wrong, but if it involves making an actual table of values, I bet they're asking you to take values on either side of 0. So like you could test 1, oops, and like a half, and maybe even a quarter, and the negatives of those as well. So you plug in 1, you get 1. We plug in a half, you get 2. And you plug in 1/4, you get 4. -1 is -1. -1/2 is -2. -1/4 is -4. And so as x gets closer to 0 from the positives, we get increasingly positive numbers. As x gets gets closer to 0 from the negatives, we get increasingly negative numbers. They're going opposite ways. Yeah, please do, Lucas. John Smith asks, I assume it's just a for fun question, but which one is bigger? 2 to the 100 factorial greater than, less than or equal to, greater than or equal to? I assume they wouldn't be equal to. I mean, we can just throw that in though for fun. Or 2 to the 100 factorial. I would guess this one just based off knowledge of functions. I don't know how you would actually prove that though. But I would guess like the factor on the outside is more important. But yeah, the reason why they kind of depend on the function is that I could name another function where they do agree with each other. Back to what Lucas was asking about. It's like whenever x squared, it actually doesn't matter which direction we approach from. Because whenever x squared looks like that, And they both shoot up to positive infinity here. So it just depends on the function, really. Hey, Phobos. Never mind. Okay. Hey, well, while we hear back from Lucas, maybe we'll go back to the linear algebra question. So Luber pointed out a mistake I made in part B, where 111 does solve it for the first row, but it does not work for the second row. And I think that means this is impossible. Is there a linear combination of these rows such that we could get some version of 111? I don't think so. But if it's not... Hmm. Okay. But yeah, like, I'd say this overall limit does not exist, but if you were to approach from the right or from the left, then you do get an answer. From the right, you get positive infinity. And from the left, you get negative. But there's other functions where it doesn't matter. So if you want to be safe, you can just always go to the left and right limits and see if they happen to agree. But yeah, I guess the teacher is flexible in the method, then it's a good thing. You thought you learned everything, but there is way more. I'm sorry, Lucas. Good luck, I guess, but yeah. Okay, I think for B, we're gonna say it's impossible because we can just never deal with the 2 minus 3 5 row. Some life advice, Colton? Sure, why not? Okay, so I think we're saying B is impossible. So for part C, there exists a vector x such that ax equals 1, 1, 1, at least 1x, and a transpose 2 minus 3, 2, 3. Oh, dang it, Loopard. You make a strong argument. But if it's in the row space, isn't it still a problem? Even if it's not explicitly in the matrix? Because you could always do row operations to get to minus 3, 5. I should rephrase maybe why it's impossible. Um, so like my phrase is definitely inaccurate, but I think it's the same idea. Coldo's saying everyone is able to make it do what they want to. Why is it so hard only for me? Everyone seems able to be doing good in life while I suck at everything. I am laughing because I feel the same way. I'm not laughing at you. Uh, people present the best version of themselves, or at least usually they try to, and that's why it feels like that. You just have to remember that um it's just not like that, even if it feels like it. And social media can make that feeling a lot worse. Um, so let me rephrase this. If 2 minus 3, 5 the row space, a matrix can always be written with a row with 2 minus 3, 5 as a row with row operations. This row will never equal 0 when multiplied. Wait, that's not how you spell multiplied. 1, 1, 1. Two math problems today in 12 hours. There's like 70 questions. Yeah, I mean, especially if it's just like a lecture where students go in, sit down, listen to it, and then leave. It's really easy to feel like you're the only one in the room who doesn't get it. Um, but I promise you that your feelings aren't unique to just you. We need an existence in uniqueness theorem for feelings, I think. Human experience is pretty universal. Yeah. Live, die, love again. Are you talking about like reincarnation? I don't know why I'm like reorganizing things. Mad Max quote? Oh, I don't remember that. It's been minutes I've seen Mad Max though. You're like, you'll ride into the gates of Valhalla, shiny and chrome. And they like spray paint their mouths with the chrome spray paint. Witness me. Yeah. You were a war boy for Halloween once? Shaved your head? Oh my god. Do you have a picture? That'd be crazy to see you as a war boy. Edible silver spray paint? I didn't know they made that. Yeah, I would love to see that. It's hard to imagine you as a war boy. Uh, you publish your yoinkity sploinkity theorem? Mm-hmm. Let me think about C. Um, you forget about the Cox Zucker machine? It's the most important thing in math, though. You never forget about it. Uh, okay, so oh wait, well, I gotta see this, and then I'll talk about part A. What? That's such a good costume, dude. That's hilarious. You really went all out on this. I don't think I've ever put that much effort into a Halloween costume. I respect this. Wow. Yeah, I don't even like recognize you with all the makeup and stuff. Committed to shaving your whole head. One friend backed out. That was supposed to do with me because I have to look good for investors. Ah, dude, it's so good. Oh, you got a tall boy bubble. John's with the YouTube set and the YouTube chat says, "Bro looks like a shirtless ghostwriter." I mean, the Warboys have a ghostwriter vibe for sure. Oh, you were. Oh, this is you're camping here. Shiny and chrome forever. Oh, you got the spray paint on there. Can see it a bit. A Psytrance Brave? Oh my god. That I'm not completely sure what a Psytrance rave even is, but it sounds like a good time. Or I know what a rave is, but the Psytrance part I don't know. Oh, oh wait, I didn't copy the link right. Wait, is that the same link? Oh, it is the same link. You got your friend with the spray paint. Oh my god, did he sleep through it? That feels like a thing that would wake me up if I got spray painted on my face. Ugh. Okay. Yeah, so Jed, for the part A bit, I'm not sure how good your linear algebra is. So I'm sorry if I'm explaining something that you already know, but um the null space of a matrix means the null space is any vector x that solves the equation ax equals 0. And so the question is to name a matrix A with these properties here. And so the column space piece means that you should be able to take linear combinations of the columns of A and get these two columns. And the easiest way to make sure that you've done that is just to include them as columns in your matrix. That's what I did in the first two. Um, but the issue is if we just left it at that, um, if we magically just remove this column, pretended it was a 3x2 matrix, the null space vectors would only be two-dimensional. And they also, like, 1 wouldn't even solve the equal to 0 requirement. So we need to include a third column of some kind. And I engineered it. I just kind of blindly added these two columns together, and I got +3 -1 +2. But that still didn't solve the equal to 0 thing. So I noticed if I just made it the negative version of that, like I flip all the signs, then it actually does happen to solve it. So I kind of lucked into it, but if you take these x's, I should really be writing probably 1, 1, 1. This column times that row is 0. The column times that row is 0. The column times that row is 0. So that's why I'm saying this is a possible matrix. It reminds me of a Sudoku problem. Yeah, I can see that. Bro, waited till REM. Yeah, for the spray paint. Yeah, I'm trying to up my linear algebra goal because I'm applying to grad schools, and it's been a long time since I took my linear algebra class, and I feel like the class that I did have didn't even cover all of the important stuff. So yeah, hopefully. So far I'm getting wrecked, but there's still a couple of outstanding applications that hopefully could come in with good news. So surprisingly, no. Some of them still so I applied to grad school. This is the second time that I've made a major push to apply to grad schools. The first time was when I first graduated college. Oh God, I guess it was 7 years ago, maybe 6 years ago. But like, in that time, almost all the schools I saw required the GRE, and but both the general GRE and the math GRE, and it was insane. I was not prepared for it. I crammed as best as I could, but I specifically avoided classes like abstract algebra, and the GRE, math GRE covers that. The general GRE completely agree. Yeah, I thought it was easier than the SAT also. So yeah, I did pretty freaking. I mean, I guess I did mediocre. I didn't do that bad, but I was mediocre, like a little bit below average on the math GRE. I did not do too well in that first round of applying to grad schools. I get into one place for a PhD, but I visited. They flew me out to visit, and I really hated it there. So I didn't. I just decided that I'd rather not go to grad school. But this time, this is a very long-winded story for a simple question. But this time, when I was looking into it, I guess because of COVID or something, a lot of schools weren't requiring the math or any GRE still. Um, so someone said they would start requiring it next year, but there were a bunch of grad schools that didn't require it, and some didn't even accept it. So It's not as necessary now. Physics Jerio's pain, I bet. Ugh, I had enough trouble with the math Jerry. I bet the physics Jerry would be just as bad. I saw my Jerry books even too that I bought to help me study. C is super weird. I don't know how to even start with this. For the math Jerry is in a different category though, and it's harder. Oh, really? I don't think I ever even looked at a physics GRE. Fembucks enjoyed the math GRE. Yeah, okay. You are kind of like that, Fembucks. I can definitely see you enjoying that. I think was I made cut-ups came out today. I don't know what that means, John Smith. Okay, this was asking the flip of the question. Let's see if people like disagree with this. Oh, this is 2004 though. Completely destroyed and glad it's over. Oh. I can't see anyone actually comparing. Oh, here we go. I bet there's not a ton of people who have taken both tests though. People got the max physics theory score. I've heard that's pretty absurd for the math one. Really? I don't remember what scale. It's maybe like 100 to 900 or something like that. I think I got like a 550. I want to say I took it two or three times, and 550 might have been my best score. I might have done even worse on other ones. Hey, color cone. Five fifty when we started about my SAT score. No, well, it depends. It's been graded out of different totals over different years, but I don't. Hopefully, they didn't actually get a 550. I hope that's a joke. What's this mean? If we transpose each side, looking for the GRE when I was applying for a PhD last year. Did you end up doing it? So it's for actually I should say I specifically applying to schools for applied math. If you were applying for PhD in regular math, the GRE requirements might be different. I think some schools did have different requirements. If AX equals 111, that means 111 is in the column space of A, which means 111 is in the row space of A transpose. Can I maximize those Jerry subject test scores? You do. I sure tried when I was taking it. It did not work out too well though. Use institutions you were interested in didn't require the GRE. Okay, interesting. So it was the same. Yeah, I forgot the GRE is just an American thing, isn't it? I guess row space. I don't know if this is a common way to say row space of A transpose, but okay. But just do the classic 111, fill in the rest of the matrix somewhere here. I don't think this line of reasoning is very helpful. Let's just give us enough space for a 3x3. I don't know if we're going to want more than that. A does have to be 3x3. Glad you didn't have to take it. Yeah, it's pretty painful. They test a big variety of subjects and they test them pretty hard. I think I was struggling with the abstract algebra so much that I decided to just call it a loss for those questions and study the other topics harder. Pi day, yep, Pi day is indeed tomorrow. Syntax. I guess, oops. Since people are here, I should plug it verbally too. I made a post in my Discord, but I don't have anything that special planned for Pi Day. But there's going to be a 24-hour Pi Day stream that's basically an entire discrete math course on Math Day Marathon. Um, it's starting at 8 a.m. Pacific time, which is 18 hours from now. And then tomorrow, Zach eats a 2i pie. Will be hosting a math trivia game that he created called 16. So yeah, those are the things I'm aware of happening for Pi Day. Yeah, John Smith. Let me drop the link to that over in the YouTube chat too. It's on Twitch and not on YouTube, but yeah. Typically, bunkers are going to compute pi. Oh my god, I bet you do syntax. Are you winning math? I sure am. Color code, yeah, you have to do all the undergrad subjects. They do not customize it to you. I still have my the book that I used. This is my math subject GRE study book. Pre-calc, calc 1. Calc 2. Oh, this book, calc 2 is multivariable calc. Up to Green's theorem. Differential equations. First order, and only linear though, and separable though. Linear algebra. Elimination, A inverse, vector spaces, determinants, linear transformations, eigenvalues, Cayley-Hamilton. Number theory and abstract algebra. Yeah, it is Fembox. Looks like abstract algebra, groups, subgroups, cyclic groups, isomorphism, finite abelian groups, group homomorphisms, rings, and fields. Additional topics: logic, set theory, graph theory, algorithms, combinatorics, probability statistics, point set topology. There's no way in hell I studied that. What the hell? Oh, I did study that, and it was terrible. Real analysis, complex variables, and that's it. Cracking the GRE, yeah. Oh wait, you know what's even better? I have this scene, right? There you go. You have it too? Nice. People actually sit through 24-hour lectures? I doubt it, John Smith. Researching gene mutations using a database of nucleotides. Now you can't be bothered to do anything else. That sounds like a lot central. Oh, but that's not. I have an even better doorstop. Oh. This is the general GRE study book, which was a joke, and I probably shouldn't have bought a book. But it's the 5-pound, which is probably two kilos or something. Book of general GRE practice problems. It's a thick boy. So that's the best doorstop. I applied for a mix of PhDs and masters, but in applied math. And I threw out one master's application for physics, just because that'd be kind of cool. Most two random variables. This is for syntax errors, calculation of pi in the range 0 to 1. The square of the fractional part of max x over y, y over x. The average of that is ln of 2 pi plus some constants. Oh my god, syntax, why? Goofy the ultimate. Good news, AI can't replace our jobs yet because AI has made 3 errors, including calculation error and vectors. That is good news, I guess. And they fix their mistakes in there, but wouldn't pay enough. I'm sure you did Central. God damn, she thick. That boy thick. You should do physics, it'd be cool. You do not get funding for a master's in the US. That's why I'm hoping to get in for a PhD. Because PhDs normally are funded. Come to UK, yeah. Wait, are masters funded in the UK? Funded through slave labor TAing? Well, yeah. But yeah, so like it in America, you can apply for a PhD straight out from a bachelor's, like a bachelor, like 4 year degree. In the first 2 years of the PhD program, you can get your master's. So if you can get through the more rigorous PhD application process, it's really worth it to try to skip a master's, like financially. You can fund anything here, basically. Maybe I do need to go to the UK. Is a consolation prize for the PhD? Yeah, like all the programs I was looking at, they just make you do an extra test or an extra dissertation or something if you want to get the master's degree along the way. And so yeah, you could um, just drop out of the PhD program after you get your master's, and you've gotten a master's for free. Like they don't like take the degree back or anything. For UCLA, picked up the master's automatically. Oh, nice. Yeah, for the schools I'm looking at, it did vary. Some you get it automatically, some you have to do an extra step. And people have gone to masters just because they didn't quite have the mark for medical school. They got in that way. Really? I wish it was funded here. You've seen their TikToks. Oh, there you go. Um, yeah, I mean, I would rather just go for a master's, uh, and then a PhD later, but it's just so advantageous to go straight to a PhD if you can swing it. That I'd rather do that. Get on STEM TikTok? I don't want to get on any TikTok. That's where the cool nerds are. You're a PhD kind of have to have a project advisor in mind. I've heard that like you really need a master's to go for a PhD in Europe. Master's where someone's used to French education. Yeah, I bet. I know why we are the way that we are, but we are. All right, good luck, Central. UCLA, we had a lot of Euromaster students in our PhD program. Ooh, really? We ended up failing the comms name. Oh, that sucks. Oh, if they wouldn't study for it, then okay, that's on them. Oh, you're getting ahead, Central. Look at you go. Central, you are such a nerd. I never would have thought, but the nerdiness is flowing through your veins. Okay, can I just name any matrix A that has this first condition and then figure out how to fix it later? The topic's energy again. I want to have 11. Oh no. We have Kool-Aid flowing through your veins. Oh yeah. It's gonna start bursting through walls. Energy in society, two things you hate the most. Ugh. Wait, okay, well, what does the second condition mean? Maybe we should start with the second one. That feels like it's more stringent. If A transpose times 1, 0, 0 is in the null space, that means that A transpose doesn't have to have a column of zeros here and anything we want for the other two columns. Like the first column just has to be zeros in order for this to be true, right? Which means the first row of A has to be zeros. Right? Yeah, what's up, Lucas? So I think my choice of A transpose is fine, right? So this can be my choice of A. A. Okay, sounds good. That's my choice of A, I guess, for part C. Every row is orthogonal to every column. If every row is orthogonal to every column, that means A times A is 0. Because matrix multiplication is just a bunch of dot products. And if the dot product is 0, they're perpendicular. Is there a non-zero matrix that squares to 0? Before that, let's address Lucas's question. Ah, journal plus plus does not like images that are bigger than the view size. Okay. The question is if you get different results if you approach from the right or the left. Oh, that's the table you're talking about. I get it. That makes sense. Does it though? Yeah, it makes sense. Yeah. So we're approaching 3. So I guess let me check your work for the sign chart there. But if your chart is correct, you would say there is a difference because one is positive, one is negative. If you plug in x equals 0, 1, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 you get a positive number, so I agree with the plus. Plug in x equals 4, you get positive divided by negative is negative. So yeah, the function is going to look something like 1, 2, 3, vertical asymptote. From the right, this is just a really vague picture, but from the right, it's going to shoot up to positive infinity. From the left, it's going to go down to negative infinity. We don't, if I don't care what the rest of the graph looks like. And so, and I'm not sure, I haven't seen that notation before with like the arrows. But in the notation that I'm used to, you'd say limit as x goes to 3 from the left of the function. Is infinity. And then from the right, I'm just going to say dot 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 for the original function. Actually, no, I don't have to be lazy. So we have copy and paste. Is negative. So in this case, there is a difference. And you can tell from the chart that you made here. So if that helps, Lucas. But let me know. Okay, Color, when you're saying to take a Jordan block, is a Jordan block as in like Gauss Jordan form? Wait, isn't that diagonal? Or what is a Jordan block? Without the eigenvalue on the... Are you saying like zeros on the diagonal or something else? Yeah, you're still teaching me Dutch, Lucas. Maybe I can just look up what Jordan block is. Oh, a Jordan block without the eigenvalues on the diagonal. So you're saying just ones on an off diagonal? So like something like that might be what you're talking about. Will that square to 0? Oh, wait. Okay, yeah, A can't be the 0 matrix. We do have a 0 column in a 0 row, but it's not the 0 matrix. Does this square to 0? I gotta do a few of these to believe it. Certainly get 0 there. Well, okay, all in the first column we get zeros because of that, and all in the last row we get zeros because of that. So then that column times each of those rows is always 0. That column, no, we get something here. That does not square to 0. You should have to have Data matrix to have Jordan, only Jordan block of size 2 with 0 on diagonal. Oh, you want a 2 by 2? I guess. We're still... Wait, are we? No, this might work out now, as you say. Okay, nice. We've seen this exact matrix before too. It seems to be a good counterexample for a lot of things. Okay, so I guess that's our choice of A. It's kind of like annoying because we're taking advantage of the fact that 0 is orthogonal to everything, but it does work. Columns add up to so part E. Um, Columns add up to a column of zeros. Rows add to a row of ones. Well, that's just not going to work. You can't have a matrix that has a 0 and a 1 in the same spot, right? Oh, wait, so if I have a row of all ones, but then also a column of all zeros, like, can't... Oh, I get it. We just make it 10. That's what they want. Well, no. You probably can't accomplish this because they don't have to be it at the same time. Jordan block J with 0 in diagonal. Size D, then J to the D is 0. Well, it didn't work with the 3x3 one, right? Unless I set it up wrong. Oh, I get it. I have to cube it. I see what you mean. Okay, yeah. And cubing it isn't relevant to the question. Interesting. Can we have columns add to a column of zeros, rows add to a row of ones? No, we can't. Because we can talk about the rank of the matrix. A column of zeros, n minus 1 for an n by n matrix. Okay. Let's check the answer on this. So this is 4.1 number 3. There's no table of contents. Oh, okay. bookmarks. Trying to not look at the other answers. That's fine. One way to use the two columns directly. A, I got the right one. For part A. Possible because null space of A and column space of A transpose are orthogonal. That's the better way to... Oh, man. I was wondering if I should think about that. And these vectors are not orthogonal. That's... Okay. I got the right answer that it's impossible, but that's a better way of saying it. Wait. I said C was possible. Hey, MQ learns. Yeah, I've been learning some linear algebra. I'd say no. I'm reading. I've been following along the MIT OpenCourseWare lectures for Introduction to Linear Algebra. In the book that I'm taking some practice problems from on 213. It's just an introduction to linear algebra. So you're probably beyond me if you're doing abstract. I'm just checking my answer to number 3. So I got C completely wrong for a similar reason as part B. I need to remember the orthogonality. So what's wrong with my answer? What condition did I not meet? So part C, AX equals 111 has a solution. Oh, this doesn't solve AX equals 111. Oh my god. I don't know what I was thinking. Okay. I'm way off with that. Part D. Rows are orthogonal to columns. It's A times A equal to 0. Okay, so he gives a different example, but I found another one. 111 in the null space, columns add to 0. Wait. No, I think I thought this was just... I don't think I did have C correct. Or if that was a counterexample, I didn't think it was a counterexample. Maybe I actually gave a counterexample as the exact reason why it's impossible. For whatever reason, I thought that if you actually took x equal to 111 and did this multiplication, you would get 111, and I don't know why. That's what was going through my head. One in the null space. It's not immediately... Oh, wait. Okay, it can't be both in the null space and the row space because they're orthogonal. Okay. What was my justification? I thought I liked my justification. Yeah, about rank. I think I like my argument too. Okay, what's another interesting looking problem? Just do number 4. If AB is 0, then the columns of B are in the... I need to remember what's orthogonal to what. The row space is orthogonal to the null space. No, oh my God. Yes, null space is orthogonal to the row space. The columns of B... Wait, it actually is kernel Chasu, or null space is the term that I'm used to, but the columns of B are basically just your x's in AX equals 0. The rows of A, by this book's terms, are in the left null space. I guess. With A equals 0, why can't A and B be 3 by 3 matrices of rank 2? Ooh. So it's not helpful here, but when you multiply two matrices, the rank of the product can't be any more than the rank of A times the rank of B. But of course, a 3 by 3 matrix isn't going to have rank 4. That's not a helpful upper bound. Why can't A and B be 3 by 3 matrices of rank 2? We should be thinking about the null spaces of these. I guess let's just... If the rank... I think, do you actually write out the word rank or is it just smaller? I don't remember. If the rank of A is 2, then we can write... Well, they could each have a row or a column of zeros. So what's so bad about that? Punching right now, none. If you have a question, feel free to let me know. Question about changing bounds for integrals? Okay. Are you talking about double integrals? Okay. Um, I always graph it. I have never been able to figure it out without graphing it. Let me find an example of one, and I'll talk through how I think about it. Hey, Midnight Angel, welcome in. Where does Paul do this? It must be in this section, right? Oh, the here. Okay, I'm just blind. If you have a question, Midnight Angel, feel free to let me know. But if you're just chilling out, that's also completely fine. So yeah, punching. Unless you post an example, I'll just take this one. Okay. So yeah, this one is definitely not easy to integrate in Y. I don't know what e to the y cubed integrates to. Probably nothing nice. So we're thinking about the bounds. Just ignore whatever's inside the integral and look only at the bounds here. So we start from y equals x squared and go up to y equals 9. So let's draw that. X squared looks something vaguely like that. Y equals 9, I'm just going to haphazardly place up here. That's the point 3 comma 9. Okay, so y goes from the parabola up to y equals 9. X goes from 0 to 3. So we're integrating over this region here. So once we know the place that we're trying, or once we know the region that we're trying to integrate over, we now need to switch our thinking. So as the integral is presented, we're thinking about like kind of like vertical rectangles because we're starting with y's. Y's going from the parabola to 9 before anything else. And switching the bounds, we go horizontally instead and start with x. Oops. So let's rewrite the integral x cubed e to the y cubed, now dx dy. So the x's, they're still starting at 0. Yeah, they're still starting at 0. So I should refill in that region. So the x's, they're still starting at 0, but this time they're going out to the parabola. So root y, exactly that. Because if y equals x squared, then x equals root y. Um, and now that we've accounted for the parabola, when we go to y, we don't have to worry about it. We can just simply look at the minimum and maximum for y. So the minimum y is 0, the maximum y is 9. And that's basically how you would do it. Like, a good check is that your outside integral should never end with a function. It should always just be numbers. Okay, good. See, I mean, if you're doing it without drawing a picture, I guess you could think about like inverting functions and stuff, but um, it's weird to me to figure out what to do with the 9 without drawing a picture. So for me, I always just draw this picture. If there's a way to do it without drawing a picture, then I think that's some Chad way that I haven't seen. Hey, famous. Two inequalities. I mean, I guess I don't quite see what you do with them immediately. I think Paul does it this way though. I don't know. He's still kind of doing it graphically. That's the thing in calculus. Famous a question for punching about double integrals. Get on that one right there. Really? Yeah, I mean, if the recording is posted, then I'd love to see an example. Because I think Professor's just being mean at that point if he's giving things that are really hard to graph. I'm gonna write arctan for inverse tan. Is this hard? If you don't know the graph of arctan, I guess it's not easy, but I just happen to know that arctan looks like that. So y is going from 0 to arctan, and x going from 0 to 1. So it's just a region like that. I could still do this graphically. Oh wait, but wait, how does this inverse functions thing work now though? Oh no, that is weird. Um, that is difficult to express x, isn't it? Okay, famished. Good luck. Let me look at the other one. Ooh, those are some funky bounds. Wait. Okay, so ln of one is 0, right? So we're integrating over some region like that. That is kind of weird. Oh, nice. Nearly done famished. Yeah, okay, I see how these are difficult to do graphically. I mean, can I just blindly do the same inverse function thing though? X would be going from, I guess, oh yeah, tan of y. No, that's fine. I think it's fine. Out to 1. And why would we go from 0 uh, to pi over 4? That's where arctan is 1. Oop, I wrote 2. No, okay, I don't think that's that bad. I got tripped up on writing a tangent there, but I think it's okay because it's tangent of y. Few more projects to do, then you have projects and introduction to programming. 2 more classes to do. That'll be semester 1. Nice. Programming is awesome. You have studied 7.1, 7.4. I have yet to do only 7.5. Your test is tomorrow? Hmm. There is a certain point where sleep is more important than studying. So if you feel like you're hitting your limit, then sleep is probably better. Save that for later in case you need to watch film techniques. Yeah, fair, fair. I don't mean that as a joke. I mean, like, if you feel tired, it's probably best to just sleep and not stay up late. You agree with the answer for the first one? Okay. Oh, let it. Oh, I get it. Yeah. Sorry. I get it now. For this one, 2x dx dy. So the x's are going, y is ln x and x is e to the y. From e to the y over here out to, I guess, 8. Y is going from 0 up to ln 8, I guess, reaching their epsilon delta, a underscore. Yeah, so these ones are weird because it makes me a little uncomfortable to have like the E and the tan, but I think the same thing still applies. Like if we could plug these into Wolfram Alpha, we should get the same answer either way. Rest for half an hour. Okay, yeah. Terms definition of four proofs. Oh my god. Yeah, I should say I've done this a million times punching, so I might make it look easy, and it's not though. I do completely like I did not do it this quickly when I was first learning it. Lucas is in like a pre-calc class that's getting into calc. Like he's doing epsilon and delta stuff, which is kind of weird to me. Okay, same answer. Um, I don't know, Cytos. Analysis? I guess so, yeah, but um Lucas is just in high school, as far as I know, so it seems kind of early. Yeah, Lucas is just built like that. Um, but yeah, like I guess like taking the inverse function is always going to be a theme, and unless it gives you something that's really just hard to draw on paper, I would try to always draw it. Because yeah, I guess like you think about it as going from from a function or a value to another function or value, I guess. It just kind of takes practice, I guess. Oh wow, even your teacher's confused. All right. Well, good night, Lucas. Covering your high school advanced math too. Wow, Jasu, that's kind of crazy. I did the most advanced math class my high school offered and didn't get any epsilon delta, and I'm kind of glad. I hope they get polar coordinates. I think some pre-calc classes cover polar coordinates. I don't know that mine did. Oh yeah, yeah. My college calculus classes mentioned epsilon delta and didn't make you do anything with it. And then in Zach's class, the first part we did a lot of epsilon delta. We did a little bit of it for infinite series, but the first part is where we really like hammered it. First part meaning like part one that was like spring of last year. Yeah, I still don't fully understand it. I understand the definition of saying, but actually executing the proofs is still elusive to me. This handwriting is kind of difficult to read. Wow. That's a Z? Wow. It's one way to draw Z. Do you want to see this? Or are you just like showing it off? Classic math department handwriting? Yeah. You want to see it? Okay. Come back to that linear algebra one in a minute. You think it's satisfying? I find it hard to read. The minuses are underscores. Yeah, exactly, Jasu. Okay. Classmates think the same. It is you. Yeah. This is an actual drawing of underscore. That's how I think you look. Oh wait, I don't know if that's a translation issue, but like you're okay. No, never mind. You get the joke. Never mind. Um. So this is gonna be a triple integral, right? I want to use cylindrical coordinates here. So in cylindrical coordinates, um, how do we do this? In cylindrical coordinates, r is equal to x squared plus y squared. Oh God, famous. I don't know why they're doing that. I don't think I want to know. Um, it isn't like tan theta equals y over x. I should verify these. I know that z equals z, and that's the reason why I want to use cylindrical. You have to compute the Jacobian myself. I should probably use these formulas there. Jacobian is just r. I cheated. Um, I don't know if it famous. That's getting a little too into like real life than I want to talk about. Okay, so polar coordinates seem appealing to me because the bounds for z. Yes, sorry. The bounds for z seem kind of straightforward. Where z is going from 0 up to the paraboloid. And in polar coordinates, we can say z equals 1 minus r squared. So if we just want a volume in cylindrical, it's r. I'll do z first, maybe dr d theta. So as I said, z goes from 0 up to the paraboloid, which in cylindrical looks like 1 minus r squared. And then R. Ooh, where does R go from? Is it just 0 to 1? That feels like it would be a sphere. Hey, Krill? Am I saying that right? This is like a multivariable calculus thing. If you haven't seen it before, it was going to look pretty crazy. Welcome in, though. It's a question from Punching. Um, yeah, R has to be a little more complicated than 0 to 1. Is it going to start from 0? It's funny because it is a circle in the XY plane. Um, so it will be 1 at the most. It's a circle of radius 1 in that like projection. But like the R out to there isn't quite right. I guess we have a dependence. Oops. Or do we already account for the paraboloid in our first bound? And we can just say R goes from 0 to 1. Maybe that's okay. Theta definitely is 0 to 2 pi, because we're making a complete circle around. I think we're good. Um, I think we can simply say R goes from 0 to 1, because we already took care of the paraboloid in the things for Z. And so once we take care of the paraboloid, we don't need to worry about it a second time, I think. um, would spherical have been a better choice? No, I don't think so. Oh, wait, I mean, usually these questions, I see them done with triple integrals. I'm sure you can do it with a double integral, but like, I guess punching it, have you seen triple integrals in cylindrical? I hope that I'm not just like showing you something completely new to you right now. um, I know that, Jasu, but I think it's pretty common for people to just say polar coordinates um, in a way to also refer to cylindrical and spherical since they're extensions of polar. Okay, so I'm just going to go through and execute this integral but punching. If you haven't done a triple integral before, then let me know and we can figure out the double integral way. Because usually there's more than one way to do these types of problems. And I think I can see the way to do this with doubles. Yeah, like I think you're technically right, Jesse, but people aren't very careful with their wording usually because it's just not the distinction isn't like that important, or maybe, or I don't know. To me, it's not too important. It might be important in some contexts, but okay. So integrating with z, we just tack a z on, and then for z, we plug in 0 to 1 minus r squared. Also, hey Obi, thank you for being more specific with what type of problem this is. R 1 minus r squared. We don't get anything from 0, so why bother? We use the word central. We're not in the jungle. We're raised by wolves. Uh, you could do a u sub with this. I think it's more direct just to multiply the r inside and integrate. 1/2 r squared minus a fourth r to the fourth from 0 to 1. Ba, ba, ba. Oh yeah, it's hard to tell when the lights are red during the day, or it's hard to tell like the light what color the lights are. I can still like feel it though. I can see the reflection in my glasses, to be honest. um, a half minus a fourth is a fourth, right? From 0, we don't get anything. So d theta. So we get 1/4 theta from 0 to pi. So we just get pi over 2. Kind of lame. It almost feels like too simple. Is there a way we can check this? It can surprise me. Oh, it is right. Okay, nice. Um, awesome. There's a double integral way of doing this too, where you think about the circle of radius 1 centered at the origin as the region you're integrating over, and the paraboloid would be your integrand. The triple integral way gets you the same thing. Like, this would be the same exact integral that you would get if you set it up directly from a double. Gotta lock in during spring break? Yeah, fair, fair. Thank you for the question. Um, oh no, he did that? Yeah, that's the Cartesian way of doing it. Um, I assume you'd agree with me that that's terrible, though. It is equivalent, but this is why polar is really amazing sometimes, because it's just easier. Yeah, yeah. Square Rhodesian? Okay, so rank A plus rank B less than or equal to n. This breaks here. Really? Where does that requirement come from, Jasu? Or well, no, I thought that I know you can have a higher rank than you have columns or rows, but I thought that idea, like if you get a bound that's more than the number of rows or columns, you just kind of throw it away because it's not a useful bound. Not to say that anything breaks. Yeah, I'm trying to think of the null space way because I know that the row space and the null space are perpendicular. Or I don't know if that's the thing that we need to use here, but I want to figure out that interpretation of this. The columns of B are perpendicular to the rows of A. What does that have to do with rank, though? If they if they both have a free variable, is it possible to engineer the free variables so that I don't know. What constraint is AB equals 0 impose? Besides what I've written on the paper here, I don't know what. Can I do a little math, please? Oh my god. You can do it 750. I don't want to recalculate it every time. Ugh. Oh my god. It was something like that. I don't remember the exact values involved here, but I think so. The dimension of the null space of A is the rank of A minus n. Well, doesn't that match perfectly? If they're both rank 2? Or n, I have that backwards, n minus rank. I guess because this implies that the rank of B should be 1. Okay. Yeah, I guess that's the answer. It's gonna take you 6 months. Godspeed's 750. I mean, they're giving us 3x3 matrices of rank 2. If you watch 18 hours a day, oh my god, 750. Three minus 2 is not equal to 2. Um, the rank of B must be equal or less. In general, yeah. For this situation, I think we just say equal to, though. Or not equal to. Or they're supposed to be equal. Oh, I'm sorry. Hey, descendants. Descendants. Children drawing. Is that what that means? 3 years old. I mean, it's bounded above um by the product of the ranks, right? I don't think it's exactly right. Okay, this is basically what I said. It's another way of saying it, I guess. It's also a mathematical object. Oh, funny. Oh, that's what you're getting at. I see, Jesu. Okay. What else looks interesting here? Actually, wait, this is 4.1. What is actually no, this is a different edition than what they're assigning from though. Man. This is actually from Strang's book, Fembox. From page 213. Because I figured out that the MIT OpenCourseWare has an actual like website with some more like resources. So I figured if like I really want some practice problems to go along with those lectures, and so what better place to actually take it from the course? Less practice problems, more proofs? Hell no. If I only ever do proofs and no practice problems, I'm not going to actually understand the proofs. uh, no, yeah, Krill, if you have a question, please do ask. This is just like a thing that I do in my downtime. Number 9 looks important. If A transpose AX equals 0, then AX equals 0. Reason AX is in the null space of A transpose and is also in the blank of A. Well, I can assume the last blank is orthogonal. Um, I don't know what else it would possibly be, but still in game theory, I've never really studied it for myself. Um, hmm. I'm trying to think. I've heard people recommend game theory stuff. No, I'm sorry. I don't have anything offhand. I wonder if someone in chat does, but I would just be going to Google and looking the same pages that you would be. I'm sorry. It's a Dessen done fence. I'm sure I'm saying wrong. It's like is an actual math thing. Oh, it's a graph. Oh, this you're Sereno? Oh, name change? Okay. Yeah, I'm sure there's resources out there. I'm not sure myself. Yeah, what's up, Ben? I guess so. I have no clue. I just see Galois group. I see Riemann surfaces and combinatorial invariance, and it's like I have no clue what any of this means. In graph embedding, I I would need to look up every like phrase in the sentence separately. Grothendieck paper on that? Oh, okay. Oh my god, Ben. Okay, we can try. 500-page document waited for bid to publish. Oh wow. Okay, let's see what Ben is going to torture us with. Um, okay. Um, the first part with more messy. I guess let me. You want to prove S of rho O times sigma, terrible sigma, terrible sigma, passable sigma is equal to S of rho plus S of sigma. Oh, it's a tensor product. That's what that thing means. The question is now on the screen. Let me organize this a bit better. So this is the question here. Chemical graph theory? I've never heard of that. Doing a very first year project. The entire deprecating society. I think the question is my attempt to proving using definitions for entropy. Same fembox. Same. Um, I'd never done tensor or anything in my life, but let's see if we can figure this out. Colded, probably half an hour or so. My voice is gonna fade soon. Entropy of tensor products makes me much tenser. Von Neumann defined the entropy of a quantum state rho by the formula S of rho equals negative trace rho log rho. Or is TR trace? I don't is rho made oh wait, it's a tensor, I guess. Rho is a tensor. Okay. And I know tensors are something like matrices. Died in the 80s. Oh. I don't know what that would even be. In this one, the logarithm is taken to base 2 as usual. I didn't even know that was the usual thing. Lambda x for the eigenvalues of rho. Right, because the eigenvalues sum up to the trace. Okay. I guess that holds with tensors. Um, or it might be slightly different. It doesn't matter. We just take that for what it is. Use a joint entropy theorem to show that this thing this is directly from the definition of entropy. Okay. Don't worry about the joint entropy theorem. The first part you didn't send. Okay. This is like throwing me into the deep end, though. That's the issue. I tried to do a proof with tensors, and I'm not completely sure what a tensor is, besides something that's like a matrix, but also not. This was, yeah. All right, oh wait, you've been here. Um, I guess I'm just gonna believe that. Hold on, this is from Ben is doing a class on quantum information theory, and this is apparently a proof from that class. Oh, Zach, you're breaking up the gaming account again. It's been a minute since you've streamed on that, at least that I've seen. Yeah, it's Danish. Ben's going to a university in Denmark. Seeing tides approach the edge of the beach. It's kind of how a tensor looks. You're doing testing on it? Oh, nice, nice. Wait, is it like a jagged matrix? Like not everything is the same size? I know it's like a matrix, but it breaks the rules of matrices in some way, and I don't know where it does and doesn't. Um, I guess you're using a log property from there to there. That's surely fine. And then you split up into two separate summations, sure. Important thing a bit later down, sum of I lambda I is equal to 1. Hey, Timberland. Basically asking how to prove the bundle theorem of calculus. I have to look at a proof of that again. It's been a minute. Oh, okay. So you're splitting up the summation based on the indices. The sum of I lambda I is equal to 1. Okay, these two sums apparently are 1. I assume that's just from the construction of the problem. Or that like the trace is equal to 1. Max loves burgers. Thank you for the follow. I too love burgers. So wait, Talking about since it's only diagonals, it should be 1. Wait, so you're asking specifically like justifying that these two things are equal to 1? That's the part that you're not sure of? Oh, okay, no. If you just know it's a fact and you don't remember the reason why, that's fine. But oh, because the probability distributions? Interesting. The math looks correct. Ooh, you're putting words in Dr. Cook's mouth. Interesting. um, can you split up a summation like that? It's simply convenient if we can. But we don't run into issues with distributing things. Oh, oh wait, oh that's not a joke. Jesse, you put a cap on it, but if you actually did it, then good luck. Um, Zappin, this is a proof from quantum information theory. I don't entirely know what I'm looking at for myself. um, you can by linearity. Okay. And Max Loves Burger, you can type them out there in the text chat or put them in my Discord. Whatever is easiest. Um, okay, well, let me just say, this step to this step looks fine. This step to this step looks fine. This to this is apparently fine. These individual summations being 1, we're taking your word for that. And then these do match the original definitions that we had up top here. So I guess having no idea of the context of this or what certain things are, I don't see an issue in it. But yeah, I'm pretty out of my depth here. It's Danish, Zappin. It's that close to German. They do share a border, I guess. Like, I don't know why it matters. um, so yeah, Ben, I guess I don't see an issue with this. That's not a very a very high bar to pass, but I think it makes sense. Or I shouldn't say it makes sense. I think it I don't see any glaring like math flaws in that, I guess. Fizbo's agrees? Okay. Makes you feel better. You're playing based on high school grades? Oh wait, so I thought I thought you were making a joke, Chasu, but you're actually applying uh, just like you're not done with school. You're going back in for round two. You're doing the bracket notation. I've heard of it as far as it being terrible. I don't know like how to read it though. When will I go for round two? I mean if we're including grad school, I haven't even finished round one. It's free? Okay, fair enough. Shannon entropy and von Neumann entropy. Oh, quantum stuff is fucking weird. This looks really weird. Why are you doing this when you're in pure math now, by the way? Why are you doing quantum information theory as part of a pure math degree? We had to pick a topic? Okay. Oh, that's right. Okay, okay, okay. I remember you saying that now. Damn. Okay, yeah. I mean, I can't even try to look at this, but good luck, I guess. Max, once you posted it, just give me a heads up if you put it in the Discord. Because I don't always see stuff in my Discord immediately. When motion theorists and their old parents said they wish physicists knew what they were doing wasn't physics. His mathematical study he was working on. Oh. um, Timberland, are you still here? Um, okay, I'm not seeing anything from Timberland who asked a question earlier but doesn't seem to still be here. And we're waiting to hear from Max Loves Burgers for their question. The physics of quantum information theory is super cool, though. That course I linked to as a tagline, quantum information is physical. Phrase everything about quantum mechanics in terms of mutual information now. Huh. Interesting. So many physics fans here? Yeah. Be affiliated to an institution to publish? I don't think you have to. High school functions? Oh, those were the options you had? Okay, until I see the question for Max, I'm just gonna go back to this linear algebra stuff, I guess. Yeah, Fizbuzz has done. I mean, I haven't seen him stream it in a minute, but he has done streams where he makes numerical simulations for physics. Oh, I didn't know that about you though, Fizbuzz. Dang. Yeah, I mean, I would have done dynamical systems. Physics and continuous matter, exotic everyday phenomena. Lattice gauge theory stuff. Hmm. I never heard of that either. AX is in the null space of A transpose. AX is in the null space of A. Okay, sure. Biophysics at the chemistry department? Wow, that's about as multidisciplinary as you can get. Drop the math. I'm a physics streamer now. I mean, I'm not completely opposed. I've been doing both. Like, I've been trying to get through this mechanics book because I really want to study general relativity. It just looks really cool. But I've forgotten so much my mechanics that I want to relearn it. Physics and Factorial Daisy. Yeah. Surf. Oh my! I haven't surfed in so long. I'm kind of full up on plans for games for a while. Like I have too many to fit in. I keep promising different people that I'm gonna do things on the same day, and I'm like, oh god, how am I gonna actually get this done? Oh yeah, Destin Ben is talking about Counter Strike surfing, which he is very good at. Simulation programs is a really applied math and computer science biological economics using classical mechanics. Oh my god, Yasu, you need to know everything. Um, I see you wrote something like that. I'm going to try not to look at it for a second. So I'm still thinking about this for myself. Um, AX in the null space of A transpose and also in the something of A. How is AX in the something of A? Am I misreading this sentence? AX is in the something of A? AX is in the column space of A, I guess. And those spaces are orthogonal, as I assumed it would be. Orthogonal. A transpose A, it's the same null space as A. This key fact should be in the next section. Okay, so what did Mega write? A transpose AX equals 0 implies X transpose AX equals 0, which implies AX transpose AX equals 0. Oh, and these are just two vectors, right? So you're taking the magnitude of them. So the magnitude of AX squared equals 0, so AX equals 0. Interesting. We're doing on this and Landau Lifshitz classical theory 1. Nowadays, science people are competing with AI. I'm gonna get one PhD out of this. Doing his PhD, he used it during his master's in physics, said it was super good but crazy hard. Oh yeah, wasn't that Dr. Cook who said he had actually read that book, Ben? I think it was him. Okay, I think we're good with number 9. I think he had seen this one. Oh, okay. Recommended. Meh. Hey, Marin. I gotta use the bathroom. I think I'm just gonna put my BRB screen for a minute. I'll be right back, guys. Okay, that heat just kind of kept on going. Let me tell you. My bladder was just like, but wait, there's more. Um. All right. Good luck, Ben. I'll see you around. I mean, AI is only gonna get better, but it seems it's gonna need. I sort of know it's always gonna need a human to I guess like operate it. Hmm. Let's think about 13. Oh, I was thinking orthogonal basis, but this isn't an orthogonal basis. Okay, this makes more sense. V transpose W takes the basis vectors for V and dots them with W, or the basis vectors for W. Is there two spaces there? There is. R is R. We're Wait, am I reading out the answer key? I'm reading out, oh my, wait, no, I'm not. This just looks like an answer though. Okay, never mind. It just kind of feels like this is just the answer. Like, I don't think there's that much to actually think about. Oh wait, I never saw something from Max Loves Burgers. I'm gonna type them too, just in case. They're like not listening to the stream. Hmm. What about 16? What is equation 2? These equations aren't numbered. Oh wait, yeah, okay. Here's 2. Okay, prove every y in null space of A transpose. It's like the left null space perpendicular to every AX in the column space. Using the matrix shorthand of equation 2, so from A transpose Y equals 0. Start from A transpose Y equals 0, which is the definition of that null space. You want to find out quantum information theory problems? Every 12-year-old knows tensors. Hey demons, how's it going? I mean, I want to multiply each side by ax. Like, but isn't this just immediately done? This is the dot product of two vectors. But I mean, I could have done this with anything else, though. Every matrix shorthand of equation, too. So what's happening in equation two? I don't quite get what they're asking to do that's different. Uh, this is the null space. I think it's also called the kernel of A transpose. Are we multiplying each side by X transpose? Where X... I'm not sure what X is supposed to be. I guess X is a vector in the null space of A. So we're going to use associativity and transpose properties to say that transpose times Y is 0. But I like, why, how's this different from... I don't understand what the question is asking the more that I look at it. I just don't know what they want me to do here. So we're doing the reverse of this statement, and we're supposed to... This is a proof of that reverse statement. I don't get how we're starting with A transpose... I still don't understand what they want me to do with this hint. I'm just gonna look at the answer because I'm a little lost by what they're trying where they're trying to lead me. Okay, I don't understand. It's just that just seems weird. I don't know. Maybe I just don't understand what's actually happening. Hmm. What is S perpendicular? Wait, what is this? Is this any orthogonal subspace, or are they defining this? It's like an upside down transpose. Where do they define S perpendicular? Orthogonal complement. Here we go. Contains every vector that is perpendicular to V. V perp. Okay. So the orthogonal complement. That's what they're asking about. Well, I think the orthogonal complement of the zero vector is all of R3. Or is it the zero vector itself? I feel like it's R3. I guess that also includes the zero vector. Orthogonal complement isn't when you say something good someone wasn't looking for. Do my paints make my butt look big? You have such a wonderful personality. That's an orthogonal compliment. Where you distract them with a different compliment to avoid the situation. Oh my god. Okay, let's try and draw out 17. Once I hear from Max Loves Burgers, I might call it soon. I feel bad because I want to answer their question, but they haven't posted it, so. Um, if S is just 0, then S perp, I'm saying, is R3. If S is 1, 1, 1, and its scalar multiples, then we get a plane. And how do you find vectors inside of a plane? When you're at war and one regiment gets a complement wrong or a heading wrong by 90 degrees. I mean, we can guess. Yeah, we can just eyeball this. Because we could do like 1 minus 1, 0. And 0 minus 1, 1. These are independent vectors. Their dimension is 2. And they're independent also from 1, 1, 1, right? I'm just checking the addition of these, but there's no way, right? The signs will mess it up. So I think that's hopefully good. Maybe I should be writing span, technically. Because it's not just those vectors. Okay, so this is a plane, and we have to name the line that's orthogonal. And we haven't learned about cross products yet. We have projections, though. Right? Or like Graham-Schmidt. I think we have that. Do we have that? Or we just eyeball it? Can I just eyeball this? Am I smart enough? What's a vector these two vectors can never get us? I guess 1, 2, 0. Because any linear combination of these two vectors must have the first two components equal, right? So if I make the first two components unequal, then we're good. I think that's how we eyeball that. Oh, dang it, it got reset. Or the thing, it's stretched. I hate it when you do that. 2017? Yeah. All of R3. I made a slightly different choice, but I think mine is also fine. I think my choice is also fine. Okay. My voice is starting to fade. I might call things here for the day. I think so, yeah. Let me make sure. Okay, I don't see anything new in the Discord. Okay. I'm calling it. If you're here on YouTube, thanks for being here. I'll be back on YouTube on Saturday.